A machine's identity is defined by its forward-facing geometry, but that geometry should always serve a functional purpose. Welcome back to True North Mechatronics. Today we're engineering the Forward Cowling Assembly. Take a look at the three components on screen. Notice the heavy use of negative space, the vertical slats in the grille, the vented arrays on the hood, and the big openings in the windshield. This isn't just for looks. This is an exercise in forward compatibility. We are deliberately leaving the accessory deck exposed with these cutouts to allow for future modular upgrades without needing to redesign the entire front end. Furthermore, by utilizing simple rectangular profiles and planar faces, we're making it simple to 3D print these parts. All three of these components will tie directly to the mounting bosses we built into the front fender panels in the last episode. Design, engineer, deploy. Let's get to the CAD. Begin by creating a new body and a new sketch, and we'll put that sketch on the XY plane. Begin by creating a rectangle, and we'll make this one symmetric around the origin. Set the length of this rectangle to 100 millimeters, and we'll set its height to 19 millimeters. All right, close that, and we will pad that out to 3 millimeters. Next, we're going to add some chamfers to this shape. Begin by selecting that back edge there, and we're going to chamfer this one. From the type, select distance and angle, and we're going to give it an angle of 7.6 degrees. We're going to set the size to 2.9999. We can't put 3, that's the thickness of our part, but we can't put 3 here because FreeCAD will not give that to us. So we can get really close, and there's our chamfered part. All right, the next thing that we're going to do is we're going to add some mounting points. So create a sketch in the top face. We're going to create 2 holes. We're going to make these holes symmetric around the y-axis. And we're going to make it so that they have an equal diameter. And we're going to set these holes to the minor diameter on our PT screws that we're using for assembly. All right, so now that we have that, we're going to constrain the location of these. We're going to reference the bottom edge of the grill. And we're going to set the distance from the bottom to 11 millimeters. And we're going to bring it in 7.5 millimeters from the edge. With that, our 2 mounting points on the grill are fully constrained. So we can close out of the Sketcher workbench and we can pocket these. Next, we're going to add the slats to the grill. So create a sketch on the front, and we're going to begin by creating 2 lines on either side. We'll make sure that we clean up that so that it is vertically constrained. Now we're going to create 6 rectangles. Now that we have our 6 rectangles, we need to constrain them. We're going to begin by making sure that they're all of equal width. And then we're going to make sure they're all of equal height. We're going to make sure that the lines that we created to start with are also equally long. So now that we've got that set up, now we're going to take this first line and we're going to make it symmetric with respect to the x-axis. We're going to take these 2 inner squares and we're going to make them symmetric with respect to the y-axis. And our next step is to make these all collinear. And we're going to do that using some construction geometry here. We're going to create a line between each one of these squares. Now, those ones are already collinear, but we are going to add that there. All right, so now that we've got construction geometry between all of these points, we're going to make sure that they're all vertically aligned. So we're going to select the geometry that didn't end up vertically aligned and bring them into vertical alignment. So the tops of all of our shapes now are collinear. Next thing that we're going to do is we're going to constrain the width of our slats. So we're going to constrain those to 5 millimeters. Now we're going to select all the construction geometry and set it to be equal length. And now that we've done that, we can set the width of the construction geometry. So we'll set this to a distance of 4 millimeters. So that tightens up the vertical array here. And then we're going to set the length of the geometry for our slots. And we'll set that to 11 millimeters. Just bring that out where we can see it. So here are the constraints that we've created so far. And now off to the side, we're going to give the last slots a rounded profile. So we're going to use create arc by 3 points. And we're going to select the 2 endpoints of our shape. And we're going to left click on the x-axis. We're going to do the same on the other line. And now we have to constrain the midpoint of these arcs. So I'm going to constrain them to the vertical line that we created. Let's try that again. Sometimes in FreeCAD you need to zoom in order to access the point that you're trying to click on. So that's what we're doing here. And with that, we have fully constrained our slotted array in the grill. And we can close out of the Sketcher workbench, and we can pocket these shapes. All right, and with that, we have completed the grill. It's got a nice chamfer on the top here that matches the slope of the hood. And so when this is fully assembled, the hood and the grill will have one continuous line. Okay, so let's move on now to the hood. Create a new body and a new sketch, and put that sketch on the XY plane. Again, we're going to begin with a rectangle, and we're going to make that rectangle symmetric with respect to the origin. And we're going to set the horizontal distance to 100 millimeters. We'll set the vertical distance to 62 millimeters. Now we're going to create the 4 anchor points that will attach the hood to the mounting bosses on the front fender panels. We will make these mounting points symmetric with respect to the y-axis. We're not going to make them symmetric with respect to the x-axis. We're going to make sure they all have an equal diameter. And we're going to set that diameter to 2.8 millimeters. All right, now let's set the distance between these mounting points to 44.3 millimeters. And now we need to offset these holes. So we're going to reference the bottom edge of the hood. And we'll set that to a distance of 5 millimeters. There we go. And we'll bring it in from the edge of the hood by 7.5 millimeters. All right, and we've got 1 degree of freedom, and that is because these shapes here have not been constrained so that they are vertically collinear. So let's do that. And now our mounting points are fully constrained, and we can close out of the Sketcher workbench. We're going to pad out this shape to 3 millimeters. And now we're going to add some chamfers on the edge of this so that it matches up with the other planar faces that it connects up to. So we're going to begin by selecting this edge here. And we're going to put a chamfer on it of 7.6 degrees. We need to select distance and angle there. So 7.6 degrees, and this one requires a distance of 2.999, so 3 millimeters, as close as we can get. We can confirm that we have our chamfer right there, so there it is. And the next edge that we need to put a chamfer on is underneath this part, so we're going to rotate up the part so that we can look at it from under the bottom. And we're going to select that edge there. And this chamfer is going to be 69.19. These are odd seeming angles, but they were determined in the prototype phase by creating datum planes, and then wherever the datum planes landed, that was the angle I used for the video that I'm making now. So you can see now we've got two chamfers. They've got different angles. This angle here is going to be continuous with the plane that defines the front of the vehicle. So this will run straight into the grille. This one here is sloped at a greater angle because this is where the windshield comes down and meets the hood. All right. Now we're going to add the vented arrays at the top of the hood. So we'll left click on the top and we'll create a sketch. We're creating a series of 4 rectangles on either side of the y-axis here. So begin by roughing out those rectangles. Next, make sure that the rectangles are all of equal length. And we're going to make it so that the rectangles are all of equal height. Now we're going to constrain the top and bottom rectangle so that they're symmetric with respect to the x-axis. And we're going to do that with the 2 inner rectangles as well. We're going to set the 2 top rectangles so that they're symmetric with respect to the y-axis. And we're going to make the left-hand edge of these rectangles so they're collinear, but we're going to do that with some construction geometry. And we'll make sure that the construction geometry on both of these are vertically constrained. Okay, so now the left-hand side of the array is collinear. Now we're going to make it so that the edges of the rectangle and the space between the rectangles are also equal. The next thing that we're going to do is we're going to make the right-hand edge of this array so that it's collinear. We're going to start by making sure that we have horizontal constraints placed on these rectangles. Now we can establish our vertical constraints. And in order to clear this up a little bit, I'm going to hide the current constraints so that we can now dimension the look of this array. So I'm going to give the length, the vertical length of this 6 millimeters. I'm going to set the width of this to 30 millimeters. And I'm going to set the distance between these 2 points to 10 millimeters. We've got 1 degree of freedom left, and it's the distance between these 2 bottom quadrants. So I'm going to set these so that they're the same length. And with that, the vented array is now fully constrained, so we can close out of the Sketcher workbench, and we're going to pocket these shapes. And with that, the hood assembly is fully complete and ready to be 3D printed. So let's move on to our next shape. Create a new body and a new sketch. Create that sketch on the XY plane and begin by creating a rectangle. As with the others, we're going to make this rectangle symmetric with respect to the origin. We'll set the horizontal length to 100 millimeters. And we'll set the vertical length to 35 millimeters. Let's now add 2 mounting points on the top and 2 mounting points on the bottom. We're going to make it so that these points are symmetric with respect to the y-axis. We're going to make sure that they are vertically collinear. We'll set the dimensions of the diameters of all these so that they're equal. And we'll set the diameter of our 4 mounting holes to 2.8 millimeters. Now we're going to set a distance between these mounting holes to 19.5 millimeters. And we're going to offset these holes from the top of the windshield. I'll offset these by 8 millimeters. And we'll bring them in from the edge by 7.5 millimeters. All right, and so with that, we can see that the sketch is fully constrained. So we're going to close this, and we're going to pad this out at 3 millimeters. So here we are. Next thing that we're going to do is we're going to add some chamfers to the edges of our windshields. Now, these are symmetric chamfers, so we're going to grab 2 edges at once. We're going to grab this bottom edge here, and we're going to rotate this shape, and we're going to grab this edge here. So, Control-click to grab both edges, and now we can add a chamfer on that. So let's maintain that view there. So let's give it a chamfer. The angle that we're choosing for this one is 13.2 degrees. And our distance on this one is, again, going to be 2.9999 to get us as close as we can to 3 millimeters. We look at that from the side, we can see we have 2 symmetric chamfers there. And the next thing that we're going to do now that we have our chamfers is we're going to create the 2 openings in the windshield. So we'll create a new sketch on the top of this part, and we'll create 2 rectangles. We'll make these rectangles so that they are symmetric with respect to the y-axis. We'll make sure that they both have equal height, and we're going to separate them by a distance of 5 millimeters. We'll give them a horizontal length of 35 millimeters. We're also going to make it so that these are symmetric with respect to the x-axis. And now we will give them a vertical height of 24.5 millimeters. So there we are. And we're going to make sure that both of these shapes are of equal length. And with that, we are fully constrained and we can close out of this. Now, we're going to pocket these, but we want to create pockets that are sloped to match the profile of the chamfers that we've created on this part so far. So what I'm going to do here is I'm going to choose pocket for these shapes, and you can see that they are they follow the normal line of our sketch, but we want them to reference the chamfer angle that we created earlier. So instead here we're going to come down and click on select reference. I'm going to select this angle here, and when you do that you can see that the pocket now follows the same angle of that 13.2 degree chamfer we created earlier. So I'm going to click OK on that. And now we have our chamfered windshield cutouts. And when we screw this onto the frame that we've created so far, this is what it's going to look like. The windshield will be sitting at an angle, and the slats will follow the horizontal plane of the robot. With that, we have completed all 3 of the parts for the Forward Cowling Assembly, and the TitanBot officially has its face. The integration between the chassis, fenders, and windshield is seamless. As always, the production-ready CAD files and STLs for these parts are live in the GitHub repository right now. Coming up in part 14, we're going to finalize the exterior shell. We'll be engineering the top cover elements for the Citadel, and making sure that the logic tray can be accessed for maintenance when needed. Chart your course, build your world. I'll see you in the next build.